Welcome to lesson 7.5. That's topic 7, lesson 5. And today we're going to be dealing with solid figures and representing them with nets. So we got some new stuff going on today. Today also, you get to see the man behind the curtain, right? Well, I need that because I need to be able to show you some three-dimensional figures. So that's not going to do on the smartboard. So here we go. Now, before we get started with our figures, we need to define a few things. And so here I have this, it's a tissue box. And this tissue box will show us everything we need to know there. It has what we call faces. And faces are flat surfaces on a geometric shape. We also have these things called edges, right? And if you can think of this as like a little, you're driving along here and you go over the edge of the cliff, right? It's that line there where we take our 90-degree turn, and those edges form lines. They connect faces. Now, edges, they come together and they form these points here, and those are vertices, or one of them is called a vertex. The plural of that is vertices. And I don't know, I usually envision the letter V coming to a point. So those are points, so they're vertices. So those are the main features of these geometric solid figures. Now, we classify these based on the shape of their faces, their lateral faces, and also what their base is. So this thing I have here is what's called a prism. And it's a prism because its lateral faces are rectangles. They're rectangles and they connect the two bases. Now, these are the bases here. We name a prism, once we know it's a prism, we name it by the shape of its base. The base is the top and the bottom. A rectangular prism any prism has two bases, one on top, one on the bottom, and they're congruent, and we name the figure by that. So if my shape was sitting like this, the bottom here, that's a rectangle. So this would be a rectangular prism, okay? We have other prisms here. Let me see, what do I have? This is a prism. I know this is a prism because its lateral faces are rectangles, and it has two bases right there, and they are congruent to each other, and they are connected by the lateral faces, which are rectangles. And we name this prism, once we know it's a prism, we name it by its base. And since its base is a triangle, this is a triangular prism. Okay, so that's prisms. We also have pyramids, and we've been studying Egypt, so that's kind of exciting. A pyramid has, like this here, this is a pyramid, right? This pyramid has triangular lateral faces, and it only has one base. It's sitting on one thing. The other side's a point, right? So this is a pyramid, has triangular lateral faces, not rectangles, and we name it by its base. Well, its base also happens to be a triangle this time. So this is a triangular pyramid. There we go. We also see I have one else. Here we go. Here's another pyramid. This is a pyramid I made from a cutout. And again, I know it's a pyramid because it has lateral faces that are triangular. It has one base, and it comes to a point there where all the lateral faces join. If I look at the base is a rectangle. So this is a rectangular pyramid. And that's the basics. That's what we need to know to move on. This is you guessed it, it's got rectangular lateral faces. Lateral means side. It has two bases that are rectangles. That's the top and the bottom. So this is a rectangular prism. A rectangular prism. And how many faces does it have? Well, it has a top and a bottom. It has two sides. And it has a front. And you can kind of see through it to see the back. So it has 6 faces. How many edges does it have? Well, the edges are here. There's 4 edges on the top. There's also 4 edges on the bottom. And then we have each corner is connected with an edge to give me 4 more. So that's 3 groups of 4, or 12 edges. How many vertices does it have? Well, those are the points. 1, 2, 3, 4 on the top. 1, 2, 3, 4 on the bottom, for a total of 8 vertices. And it's always going to be the same with a rectangular prism. So here's two more that they tried to draw. This is a rectangular prism, so we just did that. Here's a triangular prism, and again, if we looked at the triangular prism, if we wanted to count its faces, edges, and vertices, it has a top and a bottom, the two bases, those are faces, and three on the side. So this one has a total of 5 faces. It has edges, right? It has 3 on top, 3 on the bottom, and 3 connecting. So it has 9 edges. And then the vertices, it has the 3 points on the top, 3 points on the bottom. It has a total of 6 vertices. Now these faces can be broken down further into bases and lateral faces. That's lateral means side. Lateral faces. And of course it has 2 bases, um, all prisms do. And then the remaining faces are lateral faces, side faces. Okay, we talked about this just a little bit earlier. We have pyramids, and pyramids have triangular faces. Okay, they have triangular faces, and they're named by their base. So this one has a square base, so it's a square pyramid. This one has a triangle base, so it's a triangular pyramid. If we looked at the faces and edges and vertices, this one has 5 faces, right? 4 on the side and 1 on the bottom. It has 8 edges, right? It has the 4 on the side and the 4 on the bottom. And it has 1, 2, 3, 4, 5 vertices. This one over here has 3 lateral faces and a base, so a total of 4 faces. It has 3 edges on the side and 3 on the bottom, so it has 6 edges. And it has 3 vertices at the bottom, 1 on the top. It has 4 vertices. Here's a solid figure to classify, and you can kind of see through it, but if you imagine that, it's not supposed to be a rhombus, it's supposed to be a rectangle on its side. It could be a square, it's hard to tell from this, but I would either call this rectangular prism, or if you made the argument that these are all congruent sides, you could call it a square prism. But of course, a square is a rectangle, so this works no matter how you slice it. For part 2, we're looking to identify solid figures from a net.
And a net is just like as if you had taken that cereal box and unfolded it so it laid flat. It's a kind of a flat 2D shape that you can fold up into a 3-dimensional shape. And for this net that we have before us, our challenge is to identify what shape that net would fold up into. And so we want to go ahead and think about some characteristics of the 2 shapes we've learned about. We've learned about prisms and we've learned about pyramids. Now, prisms have any shaped base, but it has 2 of them and they're congruent to each other. The sides of a prism are rectangles. With a pyramid, I could have any shaped base, but there's only 1 of them, and all the faces, lateral faces, are triangles. Well, I don't see any triangles here. So my prediction is we have a prism and all the shapes are rectangles. So it's going to be a rectangular prism. But let's fold it up to see how it ends up looking. And here we go. It looks like a rectangular prism any way you want to stack it. It doesn't matter if you call this the top and the bottom, or if you stand it up this way and have a different top and bottom. We have what's called a rectangular prism, 2 congruent bases that are opposite each other, and rectangular faces. So that's it.
Big giant leap is to draw a net for a shape. And it says here in the directions that the height of this is 2 and the base, the bottom is 4 by 2. So this is a 4 and a 2, and it's too high. So what I'm trying to look at here is, well, I need to start from something. So I like to start from the bottom. So I just drew some dashed lines to try and give it a little bit of a 3D feel. But if I look at this, I highlighted the bottom, the base, and that looks like it's a 4 by 2 rectangle. Now, I'm not going to lie, this is going to take a little bit of planning here, right? We got to do some planning. So if I had that shape, that bottom, there it is. That's a 4 by 2 rectangle. That's the base. I'm going to start from there. Next, I'm going to fold down the front and the back. Next, I'm going to look at the two sides, right? And those are 2 by 2. And so you can imagine folding those 4 up and have a bottom, and now I'm just missing the top, right? So I need the top in there as well. And there you go. There are all the sides. Now, just to do a quick check, I should have 6 sides, right? Top, bottom, front, back, 2 sides. That's 6. 1, 2, 3, 4, 5, 6. I have all 6 sides, so I'm good to go. That net, if I cut that out and folded it together, I would get a rectangular prism.
Here's another net that we could fold up into a shape, and do you see the shape it would form? I'm looking at it, and I'm looking for 2 congruent bases. Well, I guess there's triangles there that are congruent for sure, but rectangular faces? I don't see a single rectangle in there. So I'm thinking pyramid, and with a pyramid I need 1 single base, and I need triangular faces. Well, this could be what we have. Let's fold it up and see what we get. And as I look at that, it looks pretty pyramid-y to me. It looks like a triangular pyramid is the shape I would call that. It's got a triangular base no matter how you sit it, and triangular lateral faces.
Here's another net they drew for you. Look at that shape. What do you see? Do you see rectangles that could be faces? Do you see a base? Do you see triangles that could be faces, or a base with that? What do you think it is? Is it a pyramid? Is it a prism? And what kind of pyramid or prism is it? Give it a shot. And we've got some straight up practice. For the first 2, you're just going to identify the solids. Are they prisms? Are they pyramids? What kinds of prisms or pyramids are they? And then we have a paragraph here describing a shape, and you're going to try to draw the net for it. So it's a rectangular prism that has a height of 2 and bases that are 3 by 1. So you could even sketch it maybe on the side to see what you think it is, and then try to draw it out. Try it, and we'll talk about it in class. Take care.